right, guys, this is lesson 3-5, day 2, extra practice. Yesterday, you were introduced, really introduced for the first time. I showed you one example on Friday last week, but you were shown again what equations look like with variables on both sides, and you were shown how to solve them. You were given examples, and I was told that Mr. Jarvinsky went through some things with you as well as the sub, and she said things went well. This is a very important concept in algebra, and it's imperative that we cover it to the core because it's just that important and fundamental to the rest of your algebra understanding. So that's why we're spending 2 days on it. Please take this seriously. When I get back tomorrow, which will be Wednesday, I will take any questions that you may have, and we will go from there. I want to draw your attention to the calendar. If you look to your left on the side of the room, you have a quiz on Thursday on 3.4 to 3.6. We will talk about ratios and proportions on Wednesday. We'll also review for that quiz, so you will be prepared for it on Thursday. Also, if you look at Friday, because of the solar-wise assembly, we will not meet, so be aware of that. All right, so 3-5, day 2 extra practice. A couple things that we have to remember, okay? We went over this a little bit, but steps for solving equations with variables on both sides are as follows, okay? The first thing that we want to recognize is when we have the distributive property, okay? When we have the distributive property, we want to use it as much as possible. So again, that's like if I have a number 2x plus 4 on the outside. When I see something like this, again, ordered operations say, well, I want to look at x plus 4, but I can't do anything with that because they're on like terms. The next thing I want to do is look to distribute that, okay? So be aware that you're going to be using the distributive property in a lot of problems, and I prefaced that when we first talked about this property. Second thing we want to do is simplify each side of the equation, okay? So if we have an equation that can be simplified on either side, we want to do that first before we start rearranging things. So look to simplify before you move things around. It will make your life easier. It will have you, it will allow you to do less steps, which in turn creates less errors. All right, step 3. We want to move variables first, okay? When we start moving things, we want to move variables first, and we want to move them to the same side of the equation, okay? They want to be on the same side of the equation because what's our goal when we solve equations? Our goal is to get the variable by itself. So the first thing we move is the variables, and we get them on the same side. All right, so now that we've moved the variables, next thing that we want to do is move the numbers that don't have variables, okay, to the opposite side, and we end up leaving the variables and the coefficients alone, okay? The variables themselves with the coefficients. What I mean by that is like I'm leaving things like 2x equals whatever numbers that were in the problem on the other side, okay? Step 5 is to solve the equation normally, okay? Once you are finished with steps 1 through 4, you will have a one-step equation or a multi-step equation to solve. Once you get to that point, you're going to solve it just like we've talked about in the past, okay? Reverse order of operations to solve. All right, so I know you've seen this before. What I want to do is just go through some examples. Some of them are going to be fractions. The last 2 examples I want you to pay particular attention to. So here we go. All right, here is an example. We're going to do the one on the left first. Okay, we have 3k minus 5 equals 7k minus 21. All right, we don't have any distributive property to use, but what we can do is say, all right, I have my k's here and k's here. So I want to move them on the same side of the equation. Well, again, we talked about this before. What would you rather move? Would you rather move the 3k over here and get a positive k, or would you rather move the 7k over here and end up with a negative k? If you think ahead of time, the answer should be to end up with a positive k. So the first thing that we're going to do is add negative 3k to both sides. So plus negative 3k to both sides. Also, I want to add the opposite on my equation, right? Because that way I keep track of negative signs. All right, on this side, 3k's cancel out. I get negative 5 is equal to 7 minus 3 is 4k plus negative 21. Okay. Next step, I have my k's all together, so I want to get them by themselves now. Step 5 says to, or step 4 says to now move the numbers. So I do the opposite operation here. I'm going to add 21 plus 21. This gives me 16. 16 is equal to 4k. And now I said, like in the steps, where now we end up with just a one-step problem in this case. Okay, one-step problem, divide by 4 on both sides, divide by 4. We get k, 16 divided by 4, k is equal to 4. All right, next problem. Nice, beautiful fractions. We're all happy to see fractions, okay? Again, this problem I'm going to add up on both sides to keep track of negatives so I know what I'm doing with them. First thing that I want to do is identify, yep, I got variables on either side. I want to use those first. So I want to add 2/3 y plus 2/3 y. Finish up. That leaves me, this cancels out, I got 1/4 equals 3/4 plus, now I got negative 1/3 plus 2/3, okay? That leaves me with a 1/3 y. All right, last thing to do is move the numbers around. So now I want to move this. I have to subtract 3/4, so plus negative 3/4 to both sides, plus negative 3/4 to both sides, okay? 1/4 plus negative 3/4 now leaves me with negative 1/2. Okay, it actually leaves me with negative 2/4, but that reduces down to negative 1/2. Now I have negative 1/2 equals 1/3 y. Okay, I still don't have the variable by itself. What I need to do is now either think of it as dividing by 1/3, but again, we never divide fractions, right? So I don't want to think of it that way. What I want to think of it as multiplying by the reciprocal. So multiply by 3 over 1, 1, multiply by 3 over 1 on both sides. Multiply fractions straight across. This gives me 3 over 2, excuse me, negative 3 over 2 equals y. That's not a good enough answer because it's an improper fraction. If I change that to a mixed number, I get 1, negative 1, and 1/2 y. That is my final answer. All right, more examples here. Moving on. Here we go. All right. This is a case where we will see the usage of the distributive property. Okay. Here is also a case where adding the opposite will be greatly beneficial to you. If you do not notice that this is actually a negative 1/2, you will distribute the wrong number onto each of these values. But if I say, all right, I have plus a negative 1/2 and plus a negative 6, I will see that I have to distribute a negative 1/2 to each of these things. So I will do that. Remember, distribute with multiplication. After doing that, I got 5 plus now a negative 1/2 of x. And I have a negative times a negative, which gives me positive 3. 1/2 times 6 gives me 3 equals 4. All right. Now I have some things I can combine. I can combine my numbers. I want to simplify before I start moving any variables. So this gives me 8 minus 1/2 x equals 4. And now I want to start moving stuff. Okay. I want to move this 8, so I'm going to subtract 8 from both sides. Minus 8 minus 8. Draw my lines to show my work. This leaves me with negative 1/2 x equals negative 4. 4 minus 8 gives me negative 4. Now I want to do the same thing as that I did in the last problem and multiply by the reciprocal on both sides, which is negative 2 over 1 or 2 and negative 2 over 1. And when I do that, I have 4 times 2. Really, this is over 1, right? So I end up with x is equal to positive 8. Negative times a negative is positive. Final answer here. All right, last two problems that we're going to talk about. I want you to pay special attention to these two because we get interesting answers, okay? My first step here is to, again, distribute this 4. So I end up with a 4f minus or plus negative 8 equals 4f. Now, what does the step say to do? Well, it says that I need to get all my variables on the same side. Now, watch when I do this. Minus 4f minus 4f, right? You can already see something weird is going to happen. I'm going to get negative 8 equals, well, that cancels out, 0. We did everything correctly. This may have happened already to you on your assignment and maybe wasn't explained to you yesterday, but I'm going to explain it now. What this means is that there is no value for f that we can plug into this equation to make it true. This equation doesn't work. So what we say is that when you end up solving your equation and you drop out your variables and you get something that's false, like negative 8 equals 0, it's obviously not true. When you get this, we say that there are no solutions. And this will happen, you will see this, okay? So again, when you get to something like this, don't freak out, check your work, and as long as everything checks out, and you end up canceling out variables and getting a false answer, that's okay, just write down no solution. All right, let's check out this next one. We're gonna get kind of an opposite event in this one. All right, so let's go through our steps. First thing that I need to look at is the distributive property. So distribute my 3, I get 3 plus 3d minus 5 equals 3d minus 2. I'm going to add the opposite here. And now when I look at this, I want to combine some numbers, right? I can simplify this side here. So if I combine those things, I get 3d plus negative 2, and that's equal to now 3d plus negative 2. All right, now you're probably noticing that, all right, this is the same as that. Let's play out this equation, see what happens. Now we say, all right, we want to solve this and we want to move our variables. Minus 3d, subtract 3d. So I get negative 2 equals, well, now those things cancel out, negative 2. All right, if we want to take this even further, we can say, well, I'm going to move the negative 2. Negative 2, I would add 2 to both sides, plus 2 plus 2. I get 0 equals 0. If you notice, these two things were the same, that was the same, and this is the same. All along the way, this was all true, okay? I can plug in any number for D, and I can get a true answer, I can get a true answer for any number I plug in for D here. And when I eliminate that variable, when I subtract 3D from both sides, I end up getting a true statement. Now, given what we did in the last problem, what do you think this is going to be? This is going to be the opposite. This is the solution is all real numbers. The solution is all real numbers. That means that I can plug in any value for D and I will get a true answer. Okay? Don't be afraid when you get something like this. It is possible. Just make sure you check your work. As long as you followed all the steps, you should be good. And just know that when you get a true answer, you're going to have all real solutions. And when you get a false answer, that means you have no solutions. Okay? That's it for now. I do want to remind you that you have a quiz on Thursday. You have class time right now to work on your homework assignment. It is further in the back of the book, not normal with the rest of the lesson that we've been doing. It's on page 826. You're going to do 1 through 21, all of them. I will look at that on Wednesday. For now, work hard and take advantage of the time that you have.